You're listening to The Bounding Box, where we talk about web development, geo development, and everything in between.
All right, welcome to the Bounding Box. Today I got a great guest here. I got Daniel Smith. So, Daniel, please introduce yourself. Tell us who you are, what you do. What's your problem?
Yeah. Hey, it's nice to finally talk to you again, Renee. We've been chatting for a long time. My name is Daniel Smith. I am the senior solutions architect at Wherebots. And so I've been doing geo for my whole career, like 20, 25 years. Um, my main problems, like I was saying, is currently age 2, 5, and 2, 5, and 12 are my main problems right now. But that's a different podcast. I think, professionally, I think my main problems are really, kind of evangelizing this newer shift in geospatial, right? Like we've gone from like that original like quantitative revolution in the 50s and the computer revolution in the 60s and 70s, the web revolution in the 2000s, and like we're getting into this space where with the proliferation of mobile devices and sensors and IoT, we have such a vast amount of data that like this new like cloud native high performance computing like kind of, I don't call it revolution, but like, big shift in how we work and operate with data is really, kind of upon us. And I think that, with that, like trying to get people to move to this new platform, right? Like we saw it with the web stuff, right? When Esri, when Google Maps first came out, and then, the early SDK wars at Esri, right? You
Yeah.
guys had the Flex API and the Silverlight API and the JavaScript API, right? Like trying to figure out where we fit there and get people to start building those types of apps. And now we're in that next phase where it's like, look, we can display stuff on the web really fast, but can we take 100 billion GPS points from cell phone data and operate on them efficiently, and make decisions with them in a reasonable amount of time, right? And can we do this every day or every hour, right? Just considering the data that's coming in. So
And we talk about like large data sets like that, right? I get this question a lot from people. Like, someone comes along, they're like, "Hey, I've got 3 million points. I need to see them all on the map," right? And it's like, "Oh, okay. Well, let's slow down a second, right? Do you really need to see them all on the map, or you need to see what they mean on the map, right? That's
right,
two different
right.
things."
Yeah, I mean, it's, visualizing large scale data versus processing large scale data versus like insights on large scale data are vastly different things, right? Like we can want to see it, but it doesn't really matter if like it doesn't make any sense in the end, right?
Yeah.
Like, just because you can make a vector tile or a PM tile with that many points, like do you really need to? Like what is your use case in the end of this data? Frequently there are people who need to see it and render it, but a lot of times they need to aggregate it and they need to do it at granularities and mapping units that really make sense for them, right? Like if you just aggregate it to the country or whatever, if you're bound by processing capability, you can only aggregate to the county level, uh, but you can make decisions at a smaller administrative unit, but you're bound by your processing power. Like that sucks. And that's really kind of where we're at with Wherebots, right? Is like this large scale, cluster computing kind of environment that allows you to process, small and large data in roughly equivalent amounts of time. I mean, it's really impressive.
So yeah, let's step back just a second, real quick. Just explain to everybody listening what is Wherebots, right? What
Yeah.
what are they? What do they
So
do?
yeah, definitely. So I think the best way to do it is start with just like a real basic analogy. So in the same way that PostGIS brings spatial capabilities to the Postgres database system, Apache Sedona brings geospatial functionality to the Spark ecosystem. And the original creators of Sedona are the founders of Wherebots. And so what we're offering and what Wherebots does is it's this kind of pay-as-you-go managed Spark infrastructure. And you can say, hey, Daniel, that's Databricks. And when you say that, I say, yeah, but when you do spatial workloads on Databricks, you're loading in Sedona, right? And you're managing all this other overhead as well. But with Wherebots, like, I mean, you get all of that Sedona baked in. You get optimizations on top of it because the creators who maintain Sedona also, build and maintain Wherebots. And so there's query engine optimizations on top of it. But there's also like additional features that we offer, right? So like large scale raster inferencing, we allow you to like kind of bring your own pre-trained models and then run them at scale in a distributed environment. we have other like turnkey solutions like map matching. So getting back to like that mobility data and the GPS data we're talking about from cell phones, like, it can be very noisy and shift around your lines. And if you're trying to do like mobility analytics, snapping that and map matching it to road segments is a critical first step in your data processing and data analytics, right? But doing that at scale with 40 terabytes of data that you get every single day isn't for the faint of heart. It's a difficult challenge. And so those types of offerings we have too. Isochrone offerings, we can generate PM tiles. We have a distributed PM tile generator, which is great. But there's also other cool stuff. Like we have a ton of ST functions and RS functions. So there's like 300 functions that you can use to process your geospatial data with Spark SQL, the data frame API. So if you're more familiar with data frames and you prefer to use that type of design pattern or coding pattern, like we support all of that too. So you get high powered computing, at the base, right? And then on top of that, all these additional features that go with it. Plus you get access to all of the original creators, right? Like these engineers and developers that we have at Wherebots are the same people developing Sedona. And so when you have a question about Sedona, like you're working with the people who build it, right? It's you're at that point you are not 3 steps removed from the people who wrote it, but you are literally talking to them directly.
I mean, that's some valuable domain knowledge right there, right?
Yeah, it's wild, man. And there's some other stuff that we've built too. I think one of the coolest things that we've built that I think kind of goes under recognized is they've designed like a pure KNN join predicate. And so if you've done KNN joins in like Postgres or other systems where you're writing SQL, you frequently do this like cross-lateral join design pattern. And it's gnarly. I mean, it's not the easiest thing to write, but they've written like it is a join based on k-nearest neighbors. And so it's really nice and elegant way to do that. So these little things and other stuff like an alias around geom from text. It's always bugged me, like, why can't we do stgeom from WKT? Like, but just putting nice little niceties like that around it are fun things that we do as well. So
Yeah, that's cool.
yeah.
I mean, talking about working with large amounts of data. I mean, there are organizations and stuff out there just generating tons and tons of data today with IoT,
Right.
and there's so much IoT just everywhere you don't even realize it, and not just stuff
Yep.
people might be carrying on them, but you have IoT devices placed out like in airports. They're tracking everyone that's walking by all these different areas and stuff, just counting, imagery, and all types of stuff.
Yep. All kinds. And you get in like the logistics as well. Like there's groups that put tags in shipping containers, and tags on the back of trucks. And so it's not just you and me with our cell phones. It's not just the sensors that are out like constantly collecting data every second and shipping it to a cloud storage environment, but it's, every asset that moves around, right? You have constant collection from emergency management folks, right? Like we see, police officers have GPS on their cars now, and it tracks constantly. And there's analytics that you can apply to that for response times. It is amazing, but it's really not just that though, right? So we can talk about big data in terms of like volume, but big data comes in other fashions too. Like working in agriculture for a long time, the complexity of those field boundaries, right? Like that gets you in a space where you have big data as well, right? Like it's hard to do large scale analysis when your polygons are extremely densely digitized. When you try to do that over all of the agriculture fields in California, where a lot of them kind of sit along rivers in these riparian zones that make really complex boundaries and really complex patterns. You scale that up to all over the globe, and like you've got a lot of complex data, not just volume wise, but it's big in its complexity, which takes a lot of computational power to resolve a join function like st intersects when those vertices, when it looks like some complex polygon. If it's a square, it's easy. So. And same with linear features too, right? Like it's not just these, but you have these big long linear features trying to do routing or trying to do isochrones across vast distances. Like they're not trivial problems. And we have the ability now to like not just collect this data, but with these distributed systems, start to actually analyze them and then do them at a finer scale to derive higher resolution insights and faster.
All this, like in the past, like 20 years ago, when I was working at county, we didn't know there was nowhere near this type of data and stuff, but we had a bunch of stuff on all of the county vehicles and the big trucks they would use to move dirt at landfills and stuff, and it collected everything from, is the ramp on the truck up? Is the truck idle?
Yeah.
What is the
Hmm.
status of the engine? And all these other different pieces
Yep.
of information that we would collect, and then we just had to process that little bit of data in-house and stuff. Even
Hmm.
that was a little tricky back then. I can't imagine
Right.
being a solo dev
Yeah.
or a small team at an
Whew.
organization trying to
Yeah.
deal with all these new data sets.
Right. And more and more are generated every day. And like that's still like that was, like you're saying years ago. And they haven't stopped, right? Like they put more and more sensors on these things and they track, like you're saying, oil temperature, oil pressure in like a, second by second interval. And so you have densely collected GPS that is both, long and wide, tons of features that go with it, and trying to like do analysis on that. And like be able to like actually make operational decisions, you've got to be able to analyze it that day. I mean, in agriculture in a lot of areas, like in construction like this, right? Like if you understand the cut fill that was taken out, you understand all of these things, and you can make a decision for the next day without having to go out, without having to do all these things. And even on top of that, with all that sensor information, you're able to like analyze and do like proactive maintenance on these things, so you save money there. Like there's all kinds of different things that you can do with it that now you can actually do with these large scale systems.
It always pissed off the field guys 'cause when they started doing that, just started putting them in the trucks too, and enabling geofencing, right? So like if they're like, "Hey, you guys are
Yeah.
way outside your service area," they would get like a message on their phones or something, ping the
I get
pagers.
alerts,
Yeah,
right? Yeah. Yeah. The geofencing stuff is cool. There was an application that I wanted to use and I haven't seen it in a while called Tile 38 that was like a geofencing server that I should probably check in on. I haven't seen it in a while, but those types of live applications are something that we support as well. Like so you can use like Sedona, with Flink. So if you're like, a Flink user, like it dovetails right in there. But then the inbuilt like Spark structured streaming stuff, like you can collect that data that you're talking about here and just like push it through a Kafka stream and right into Spark structured streaming and write it directly into your Iceberg tables, into GeoParquet, like however you need to go. Which is another thing that we should probably talk about is the migration to these cloud native formats like Iceberg. Like, I mean, I see that you guys over at Esri are starting to support GeoParquet and Parquet, which is fantastic. Like, we're super excited about that.
there's new Parquet layer beta in the latest Maps SDK release, right? So
Yeah.
there's some excitement around that from some people, so it's pretty cool. I haven't had a chance to play with it
Yeah.
yet, but yeah, that's fun.
Yeah, yeah. I mean, it's such a nice way to go about like storing this level of data and this volume of data, right? Like the pre-computed bounding box and the statistics that allow you to like pre-filter from all of your files. I mean, it's been a dream to work with. After I've been at Wherebots for about 14 months now, and like I said, I've been doing geo for a long, long time and large scale analysis for a long, long time, and being able to like actually process this data and like not have errors and like derive my results in like a matter of seconds or minutes. I mean, I've got a performance demo that I run that, we extract all of the places data from Overture Maps Foundation and all of the building footprints for Overture Maps Foundation for the entire country. I can draw this big bounding box. It's a fun little demo. And so I draw this big bounding box over the whole country, and then generate hexagons across the entire field, and then do a spatial join just based on intersection. So I'm not doing something crazy like completely within. But like that whole like flow, like those three simple steps, right? Let's extract building footprints from, I think that data set's 60 million building footprints right now. The places data set, global places. We can actually extract that in like it takes a matter of seconds, to be honest. Like it takes seconds to actually extract that data from the Iceberg tables and why we use our data catalog, and then generating the hexagons and spatially joining it happens in about 10 seconds. Like it is a
That's nuts.
phenomenal show. And it's wild. And what's crazy though is that when we start the demo, like I draw a little box like around like Southern Illinois, and run the analysis, and it takes a couple of seconds to pull these things out, generate, do the join. Then I scale up to like the size of the state, and you run it, and then you do that several times. But then you start to graph that runtime, and it's non-linear, right? In a lot of systems, like you would expect, if I have 100,000 points and it takes 10 minutes to process 200,000 points, it's going to take 20 minutes. But with these distributed systems in Sedona and Wherebots, like it's a non-linear performance increase. Like you're running, excuse me, the same analysis over, orders of magnitude greater, and you're getting differentials in time like in the matter of seconds. Like it's from like 5 seconds to 6 seconds when you go up in order of magnitude. And so you're really able to do a lot with it in a short amount of time. And like just iterate faster, right? Like being able to do this stuff allows you to like, oh, well, that analysis was wrong. Like, like I did that the stupid way. It needs to be done like this. And then you need to kind of go back and redo it. And if it's kind of a slower single threaded system, like it takes a long time to go through. And so this allows you to really just kind of keep going and iterate through your process.
I've always loved seeing stuff like that. Things that just run analysis that runs so fast today that would have taken me like a week, 2 weeks of just iterations and stuff just to get maybe a dozen type iterations out to get a final one. And now you just run these
Right.
other analysis so fast today. It's like done like in an hour, half an hour if you're lucky, right?
Right. And you're just like, and you spend more time like validating your
Yeah.
results than you do like running it, which is a nice change, I think. I mean, you get to spend your time doing other things, which is nice. But it's just great to see it. And that's the other great thing about the platform is that we really interoperate between like high scale and high performance like vector computing and raster computing like within the same SQL statements, right? Like you can do a KNN join to derive your nearest coffee shop from all of your buildings or whatever you want to do, and in the same SQL statement, like with that KNN join, do a raster analysis on the vegetation in the area, like in the same code block, and you still get that large scale performance. And not have to jump out from like Google BigQuery to Google Earth Engine, or have to surf between these purpose-built systems for one data model or another. So
Nice.
yeah,
So
yeah, I really like it.
this question for you, how did you get involved in all this, right? So you've been doing geo for a long time, right? But you weren't always
Yeah,
doing geo like this.
no, yeah. Yeah, it's really interesting, man. Like I did consulting, and this is something I've been thinking about a lot lately. Like I did like real traditional geospatial stuff, since the beginning of my career, right? Like, went to university, studied, and all the shops and all the labs are on the Esri platform, which I, still know and love to this day. And then like you start to see this career. So I was a consultant for a long time. And then I would say it was late 2019. There was an opportunity to move towards like big tech, right? And so there was this machine learning company called Data Robot, and they had an opening for a geospatial specialist and a solutions architect. And miraculously, I convinced them to hire me. I don't know, why the hell they did that, but they did, and it was worked out really well. And like we grew that team, and then we did a bunch of COVID work because that was 2020 rolled around, and we went off and did a bunch of COVID work, and it was I think really insightful for them, because that group was more based on your real traditional machine learning at the time. This is before Gen AI, right? And so the machine learning there is real like predictive, so XGBoost models and all that kind of stuff, random forest stuff, and they knew the value of geo, and we had a small geo team doing mostly at that point it was feature engineering, right? And so it's using advanced spatial statistics for feature engineering to feed these models, because these machine models are so damn hungry that they'll take whatever you want to throw at them, right? So we were building tools for like correctly doing like CV splits, right? So you're testing and control splits on your machine learning data. You have to be really careful how you do that when you work with geospatial data, because when you build things like we were, like with K nearest neighbor, we were using K nearest neighbor features there, measures of spatial autocorrelation, right? But to do those things correctly in a machine learning, you have to pull out data from your data set for holdout, right? For testing, for training, and for holdout. But if you do that incorrectly with geospatial data and you're deriving these structure-based features, right? K nearest neighbors, if you pull out the wrong thing in the wrong way, your nearest neighbors are now off because you've removed them from your data. You've broken the structure of your data, right? And so like you have to do these things really intelligently. And that's what we were doing there. And that was my first introduction from going from like, we're a bunch of analysts and cartographers and environmental scientists and soil scientists to like, we're engineers. It's that dichotomy, right? There are people who are geospatial people who have a programming problem, so they learn how to program and automate, and then there's engineers who have a geospatial problem, who know the engineering side and are getting into this geo. And so that's kind of where I made that switch, was in 2020 going to Data Robot. And it was just fascinating. And I just, I took a chance trying to like get into that area, and it worked really well, and it was great. And I kind of moved from there to another large scale computing company called Heavy AI, and it was a GPU based system, which is great. Heavy is an amazing platform for running large scale analytics against GPUs and visualization. They've got a really nice dashboarding system that's kind of inbuilt to their platform. It's kind of core to their offering. And then I started to kind of perk my ears up, and I saw what Wherebots was doing. And I had played with Sedona, used to be called GeoSpark. And so that was its name originally, but then it became an Apache Foundation project. They changed the name to Sedona, went into incubation, and when it came out of incubation, that's roughly when they started to form Wherebots. They did their seed round funding, and that's when they kind of popped up on my radar. Was after that I started to look into it a little bit more, and it worked. Like I went and I grabbed a community edition, and it just worked, Renee. And I was like, this is really fascinating. And at the time, I applied for a backend. It was like some sort of like a database backend, like a junior engineering role. And I'm not an engineer. I was like, I just want to work with these guys. This shit's cool. And they said no. They're like, no, thank you. You're not qualified. And I was like, all right, that's reasonable. Like, I'm not an engineer. I figured I'd try. And I think that was about a little over 2 years. I started in April of last year is when I started at Wherebots. And then a few months later, like I kept seeing stuff pop up. The DevRel guy, Will Lyon, super cool dude. I kept seeing posts from him on LinkedIn, just the cool shit that they were doing, how fast it was. And I just shot my shot, and I just like messaged the CEO on LinkedIn. I was like, hey, I don't think you know me yet, but I'm your new solutions architect. And so we should probably see what we can do together, since I'm going to be there soon, something roughly like that. I mean, I don't think it was as informal. But Mo, who is an amazing professor, an amazing CEO, I convinced him. I convinced him to kind of, he's like, I'll bite here. Let's chat with this guy and see what he's got to say. And from there, like, it just kind of, went quick, and, joined on, and we've been doing, building use case libraries, running all of the demos, doing POCs, onboarding people. It's just been, the past 14, 15 months have just been a whirlwind of activity within Wherebots. I mean, from seed to Series A, all of these things. And, we're at conferences nearly every month, it feels like, and presenting at, various workshops. It's been a ton of fun. We've had great growth. We hired Matt Forrest. And so hopefully Matt said, hey, Matt, I hope you're listening. He does a great podcast as well. And so we just had, tons and tons of growth, and just getting busier and busier, and just exposure to lots of new groups and new companies, which is really fascinating, right? Coming from this geo background, like, you're taught, it's not really discussed in from what I've seen. And I've been out of university for a while, but like, you're taught this specific geospatial stack, and you're taught this like way of thinking about it is like, you're an environmentalist, and like, there is so much geo out there that it's insane. And I don't think that enough people are exposed to the reality that like Zillow, they have a huge geospatial shop, DoorDash, and like, it just kind of goes past people that like, underneath Google Maps or Apple Maps, there is a huge geospatial engineering staff. I mean, they have so much going on, and it's wild. And I don't think that we're doing enough within the geospatial community, from like the lower level folks, right? From the younger folks, to say, hey, like, it doesn't have to be maps. I haven't made a map in probably, since 2020, since COVID. We're working at Data Robot. I think I've made a reasonable map. But you can do all these other things with it. And like, to just think about it in the context of, a county government, or, some sort of site selection model, doesn't really get to the depth of and the breadth of what geo is now. I mean, 2 decades ago, it was counties. It was that, now it's, it's logistics companies doing large scale routing and analysis. It's insurance companies flying drones over disaster areas. There's a company that we talked to a while ago. that they're like starting to look at using satellite imagery with cities to do like like reinforcement of like enforcing fines, right? Like just tracking, like, is this car broken down? How long has this car been here, right? And so like flying satellite, using high resolution satellites or flying drones or whatever, like, these are not use cases that are discussed deeply from my experience. Like I said, I should probably go back and do some more research before I say this, but like those type of use cases and those type of companies like really aren't, from what I've seen, like discussed. And it was amazing to see it. And in the last 5 years of being outside of consulting and more in like geo big tech, to see that plethora of use cases across the board, like it's, what people do is wild, man. People build such cool stuff and such cool analysis. Like I didn't even think there'd be anybody who would do that. And
It's
you guys
true.
are building it and making money.
It is a trip, man. I mean, I see posts like on Reddit a lot, like people going into college or graduating from college, and they have these geography degrees and or some other related field degree. They're not sure what to do. What can I do? And it always boils
Yeah.
down to like, well, okay, there's local government, you got federal government, you've got defense you get into, you got geo
Right.
you get into, but this like analytics type stuff isn't really mentioned very often. Like I'm guess
Yeah.
my guess is a lot of people in the field have computer science or related backgrounds that just kind of
Yeah.
fall
Yep.
into it and they learn the geo
Yeah.
part after the fact, right?
Right. And what's interesting about that, and same with like the engineering and the architecture side. So it's not just the analytics, but like you've got so many cloud offerings now that have so many different features, and like trying to plug everything in together to like work with these large companies, these large stacks. Like you're not thinking all the time about like the geospatial analysis, right? But you're trying to build these Lego pieces together to form an analytical platform for somebody and then do the analysis, right? And to that point, like there is something that's I don't want to say lost, but not, how do I want to phrase this? It's not like it's not always a first class citizen. And I know that like, people are like, geospatial is special, and people are like, no, it's not special, it's common, like, and then like I think both of those things are true, right? Like it is ubiquitous, right? Like it is ubiquitous. But at the same time, there aren't many data types out there that require a pair of values or a string of pairs of values to make sense, right? Like most things are individual by themselves, but like an X doesn't matter without the Y and vice versa, right? And so it is kind of special. And understanding the caveats and the eccentricities of working with geospatial data, really kind of needs to be factored in when you're architecting these systems or you're building, analytical platforms, right? A data scientist will say, cool, here's a map, I can aggregate it to the county, but do they understand like, why you need to do joint count statistics, or when to use spatial autocorrelation and how to do it correctly, or like what the modifiable aerial unit problem is and why that's important to consider when you're trying to make decisions based on aggregated data. Like these types of little nuances that we learn about in geospatial school that I don't think are taught as in depth within the broader data science community. Like we have a lot of value to bring across industries, as people who study geography, as people who, study geo as a system and as a science and as a collection of systems and science, and I think a great example, we were talking about a use case where these folks they're doing drone collection of power lines. We're sitting there talking about it, and we're working with a consulting group who's actually working with the company, right? But they've got tons of data and machine learning models, and they can't analyze it all. So they're coming to Wherebots to provide that large scale platform. And we're talking about kind of the next step and what they're going to want to see. And we're sitting there kind of talking about it, and they're like, yeah, well, we're not really sure what the dashboard's going to be, or what they're going to want to see. And it's like, well, I can tell you right now. I can look outside and tell you what I think that they're going to want, right? Like somebody who studies geography, who thinks about space. Like we have a lot of value to add to these things where engineers might not spend that time. And like I mean, you can just look outside and say, oh, I'm going to want to know how many miles of power line they've reviewed, how many how many miles are left. What are the highest priority things that we found that we need to go fix? What are the things we need to do preventative maintenance on, right? Tree strike area type of analysis, or squirrel nests in the next to the transformers and stuff like that. And so there's a lot of hidden value, and I think that's really where I have really where I think made my mark within Wherebots and that Data Robot is just, having that geospatial knowledge and being able to bring it to an environment that hasn't really thought about it as a first class citizen for a long time, right? Like, if you don't know that changing your mapping unit scale up and down affects your results, then you're just going to say, oh, county, here's county, and we're done, right? It's like COVID, right? It's like when you're doing COVID maps, like looking at the county level versus the state level, like you get two very different pieces of information when you do that.
Oh, that's awesome, man. I really appreciate that. So I want to be respectful of your time here, but before I let you go, you got any tips, tricks, words of advice for listeners out there? Anything at all?
Yeah, I mean, I think just, keep going, just keep charging. Like it gets weird out there when you're working in a professional environment. And it can get weird with geo, like we were talking about. Like some people, try to grow and they don't want to do the county thing or the environmental thing. Open your viewport when you're trying to look for careers, you're looking to do stuff. Like there's so many people out there. And the other thing I would say is contribute to open source. Like go look at open source technologies, look at open source offerings. And they're out there. I think on that same level, I'd ask your listeners to contribute to OSM. The OpenStreetMap project is a huge boon to all of us in our industry. And, as we see more and more public data sets kind of be removed from the public eye, having community action and community effort to either collect or preserve what's there. And we've already, frankly, paid for, Renee. Like it's legitimately ours already.
Exactly.
And being removed is a little yet again another podcast that we can do. I'd say that this is an interesting time for us at a geospatial level, in the data level. And like I think that it's important for us to kind of keep that in mind. I know that's way off topic and not really what we do here, but
No, but it's true.
I think it bears mentioning.
It's true, right? I mean that data is disappearing, and we don't know if or for when we'll get it back. So
I agree. Awesome.
All right, awesome, Daniel. I appreciate your time. Thank you very much.
Thank you so much, Renee. Cheers.
Thank you for listening to the Bounding Box today. Please subscribe for more content.